Hello, students. Hi, everyone. Welcome to today's lesson. Okay, today's Monday. Okay, so we're back to lessons again. Okay, I hope that you can hear me. Can someone please put a message in the comments? Everyone, good morning. Okay, can you tell me whether you're able to hear me so I can continue? Is my audio here loud and clear? Please give me feedback. Okay, 5S4. Good morning, Joanne. Yes, good morning. So please let me know if I'm coming across loud and clear. Okay, good morning, Yilin. Good morning, Peishan. Okay, thanks for the feedback, Yilin. Okay, so you can hear me, right? All right. So let's start lesson. Today, lesson will be a bit shorter because we have split 10.1 into two lessons. Okay, last Saturday we had a class that was, I already covered half of the factors. So today we continue with pollution, the different types of pollution, and also the human population explosion. Okay, let's look at today's. Let me share screen. Okay, I think you can see this, right? Okay, let's look at this. So we have actually seen, all right, last Saturday, 2 days ago, we have already done climate change and global warming, deforestation, loss of biodiversity, and eutrophication. Then today we go on to the last two parts, which is pollution and human population growth explosion. Okay, so let's go on straight to pollution. So there are actually now, when you talk about threats to the environment, remember all these five factors. Okay, according to textbook to be five, but here it's split up into six. Okay, doesn't matter as long as we talk about these few factors here. So today we're going to cover pollution and also human population growth explosion. All right, okay, let's go on. Let's carry on straight to pollution. Afterwards, in the Google Meet, we can revise a little bit on the eutrophication. Okay, when we talk about BOD, the biochemical oxygen demand. Okay, let's go to this one. Yeah, pollution. Okay, this is where I stopped now on previous lesson. So if anything, please just put a comment in this chat box here. Okay, now pollution. What is pollution? In BM, is it pencemaran? Okay, so this pollution is actually across all the subjects. You learn about it in BM. You also learn in BM lesson, in English lesson, in your PJK, I think so, okay? And also in science or biology and physics and chemistry. So pollution is a major issue nowadays. Pollution, what does it mean? This is an undesirable change. Undesirable means something that you don't want, something that is not good. That's called undesirable. Okay, so something has changed. What has changed? In terms of the chemical composition or the physical or the biological aspect of the nature. So something has happened to we call it our natural surrounding, our ecosystem. Okay, or we say 大自然, our nature. So something has happened and it's undesirable. Something bad, that means it's making it worse. Okay, that is called pollution. So we have many aspects of pollution. Whether you're polluting the water, okay, whether you're polluting the sea, water, of course, it refers to the sea, the rivers, the lake, and so on. It also can come, we can talk about pollution of the air that we breathe in. So there are many aspects of pollution, okay? So pollution affects soil, river, seas, and atmosphere. So there are many aspects of it. It will threaten the life of humans. Okay, so humans are affected because we may have respiratory diseases or we can have poisoning if the water is dirty. And also, of course, that happens to animals as well. Okay, and also the plants. So let's look at the four types of pollution. So I want you to remember the four types. Just look at the acronym WANT once. Okay, so four types. W stands for water pollution. A is air pollution. N is noise pollution. T is thermal pollution. So it's very easy to remember. You remember WANT. So there are four aspects of pollution. I mean, four different types of pollution. Okay? So, pollution is any substance, a pollutant. Okay. Okay. Something that is able to pollute the environment is called a pollutant. Pollutant, it means it's the substance. Pollution is a phenomenon. Pollutant is the thing that makes it dirty, that makes your environment dirty. For example, it can be the chemical, it can be any substance that is able to make the water or the air dirty. Okay, so it's present in excessive amounts. That means it's too much. too much to the extent that it will affect the livelihood. Okay, sorry, cannot see the screen sharing. Oh, sorry. You're not able to see it. We can't see the screen. Oh, okay. Let me try and share again. Let me try and share again. Sorry. I think I am sharing already. I don't understand why. Let me try again. Sorry. Okay, are you able to see this? Okay, I'll wait for your response before I carry on. You cannot see the screen sharing. That was 3 minutes ago. I'm so sorry. Now can see. Okay, thank you very much, Gianni. All right, so sorry. So I am just looking through this one. This is what I already mentioned just now. What is the meaning of pollution? Is undesirable change. Okay, that is not something that is good. In terms of chemical composition, physical or biological characteristic of the, okay, so you can see it. Just now I think there was some problem because I was actually sharing it. Luckily you told me, because I wouldn't have known it. Luckily you let me know. Okay, so pollutant is anything that is going to harm the environment. It's a substance. 那个物体就是 pollutant. And then the pollution is a phenomenon. Okay, it's something, it is the phenomenon. So don't use the wrong terms. Okay, 4 types of pollution: WANT, water, air, noise, and thermal. Let's look at one by one. Air pollution. Okay, let's look at the first one. Air pollution is caused by the presence of pollutants, usually gas. Okay, usually smoke. You can also be particles. Smoke is in a form of gases. It's a form of particles. Okay, when you burn rubbish, you're going to get this soot, S-O-O-T, soot. Soot is actually carbon release. Okay, carbon release. Okay, Jin En can see, right? Dust is also particle. It's not gas. Dirt, dust is particles. Smoke is poisonous gases, okay, which are harmful. So let's see what is the source and what are the pollutants. So the source means you get the pollutant from. What you do when you what have air pollution is because you do this. You burning of rubbish, burning of forests, or burning, okay, whether purposely or intentionally. Purposely because the forest, unintentionally because of the drought or the heat wave, the forest can can just sort of like burn on its own. Okay, if it's too warm and too hot. So pollutants, what do you get when you burn? You definitely get carbon dioxide. Don't forget, that's what my last lesson said. When you burn anything, you will have carbon dioxide, because carbon combined with oxygen, you get carbon dioxide. You will also get the particles that are released, usually carbon. Why is the smoke black? Because of the carbon. So you have soot, you have dust, you have smoke. Smoke is gases, right? Smoke is a general name for all the types of gases that is and also black color that is in the that's released when you burn. Okay, it's combustion. So burning and combustion is the same meaning. Combustion of fossil fuel. Okay, what do you burn? You can also burn fossil fuel when you drive your car. You're burning petrol. Petrol is a fossil fuel. Diesel is also fossil fuel. Everything that comes from petrol, including coal, okay, and also natural gas, because they come from the bodies undergoing changes of these dead animals millions of years ago. Okay, so any problem now so far? Okay, okay, then next one. Sorry, here you get pollutants are the sulfur dioxide. Remember the topics, remember the names. Sulfur dioxide and nitrogen dioxide. These two are responsible for acid rain. So please remember gases that causes acid rain. Okay, motor vehicles release exhaust fumes. They will also have carbon dioxide, more dangerous than carbon dioxide. Carbon monoxide actually poisoning, that it takes over the place of oxygen. So hemoglobin combines with carbon monoxide and is delivered to your body cells, and animals cannot use that carbon monoxide. So the person will die because of oxygen. Okay, and soot. Lead will release when substance that you burn contains traces, so you will get lead release. Okay, agricultural use of agrochemicals, okay, like fertilizers, pesticides. Fertilizers is to make the plant grow better. Pesticide is to kill the pests that kill all these insects that eat your plants, kill the rat that eats your plants. Okay, insecticide is more specific to the insect that eats your plants. Pesticide is not insect, but it kills, let's say, for example, frog. You can kill this. What else? Pesticide, rats and all that. They are called pesticides. As long worms as well. Okay, so they kill off all these things. Herbicides are those chemicals which kill the wild grass that, if they gather with your crop, they will compete for the nutrient of the soil. So you want to kill all these weeds without killing your plant that you want. Okay, so you have pesticides, herbicides, and herbicides. So slightly different. You see the word "side", that means it's to kill something. Okay, you have homicide, suicide. I know suicide, right? Suicide is to kill your own self. That is called suicide. When you see the word "side", it means killing. So pesticide is to kill pests. Insecticide is to kill insects. Herbicide is to kill the herbs. Herbs means the lalang, the plants that you do not want, that is actually competing with the nutrients for your plant. So you want to kill it off. Okay, next one. So look at this carbide when it's released into the air. Sulfur dioxide and nitrogen dioxide also, when they release into the air, they will dissolve in the water. Where is the water? The water is in the water vapor in the air. Okay, so you don't have to worry about all these chemical equation. Okay, don't worry about this. This one you leave it for your chemistry. In biology, you are not needed to write all these chemical symbols. You are not needed to balance it as well. All you need to give the correct name. So though you're not good with all these chemical symbols, okay, you just need to remember when it comes to nitrogen oxides, there are two types. There's nitrogen, there's NO, and there's NO2. Okay, NO and NO2. For sulfur dioxide, always SO2. Sulfur dioxide is dioxide, di means two. SO2 is dioxide. When they talk about nitrogen oxides, why do you say nitrogen oxide? Because there are two types. So you have either NO or NO2. That's why we call it collectively. These are known as nitrogen oxides. Okay, so you have NO2 and NO. And also carbon dioxide, when it dissolves into water, you get carbonic acid. So all these are acidic. All these are acidic. And it is harmful to the environment because it's going to increase the acidity of the soil. Okay, okay, let's look at this one. Let's look at acid rain now. So when you have a lot of this burning, these gases is, you end up increasing the amount of acid rain, okay, in the atmosphere. So when it falls into your plant, it increases the acidity of the soil. Okay, let's look at here, acid rain phenomenon. So rainwater is naturally acidic. Okay, so rainwater normally is about 5.6, but if you have acid rain, it will be even more acidic than 5.6. You'll become less than 5. Okay, so that is not good for the soil. You have soil a little bit acidic, it's okay, because every plant will have a tolerable range. It can tolerate certain range. If it's too acidic, okay, then it's not good because the plant may not be able to live properly. And if it's too alkaline, also it's not able to live. Okay, so it has a range lah. It cannot be too high, it cannot be too low. Okay, now look at this diagram. This diagram will help you a lot. Contains, just remember, sulfur dioxide and oxides of nitrogen. What is nitrogen dimension? There are two. Okay, so you have SO2, sulfur dioxide, and also NO2 and NO. So these come up from smoke from the factory. Okay, and what happens is when they go up into the atmosphere, all right, it actually dissolves in the water vapor, in the clouds, and what you get is these type of things. You get sulfuric acid and sulfur dioxide dissolved in water. You get sulfuric acid. And nitrogen dioxide and nitrogen monoxide dissolved in water. You get nitric and nitrous acid. Okay, so which is the NO dissolved in water? You get nitric acid. The NO dissolved in water, you get nitrous acid. Doesn't matter as long as you have these two nitrogen oxides, you get this nitric acid, nitrous acid. Okay, and they form your acid rain. So now it drops onto the ground, right, into the ground. And what is the effect of acid rain? So what's the effect? Let me check your here, nothing. All right. So let me look at the effect. Now, first of all, it affects our structure. Okay, the human or man-made structure. Number one is your metal. All these metal parts. Okay, metal will corrode very fast when it comes into contact with acid. Okay, you learned that in Form 2 before. You put zinc into acid, hydrochloric acid, it produces hydrogen gas. And you can find your zinc here will appear over time. Okay, slowly actually becomes ion. The zinc actually goes into your acid and is being from zinc chloride. Okay, sorry, from zinc, it becomes zinc chloride. So it becomes an ion. So it will corrode, okay? And it also produces rusting. So you have acid rain, it increases rusting. So this is also a reason why maybe near the sea, like for example, Penang and so on, you find a lot of the structures here that you have in the house and all that, you find that it rusts a bit faster because the wind of the vapor coming from the sea is acidic. So people who live by the seaside, they'll find a marked increase in the rate of rusting. Okay, people say the 海水 okay, the water and the vapor from the sea, because if high content of water, we call the acid, it sort of like increases and promotes rusting. Okay. Second, soil. The effect of soil to the soil becomes acidic, so not all plants are able to live in it. So the soil becomes less fertile because not suitable for the plant. Okay. Next, what about the water source? River and lakes, they turn acidic, and when it turns acidic, it will harm the aquatic animals. They are staying there. It kills the animals, it kills the plants inside the water. Okay, lakes and so on. And what about toxic metals such as mercury? All right, when it comes in contact with the acid, sort of like it will leach, it will go into the river, and then you will have these poisonous metals, we call it toxic metals, heavy metals, deposit into the river and the lake. So it sort of like increases this content of the mercury. Next, mercury, you will have cadmium and nickel. They are called toxic, not toxic, it's called heavy metals. Lead as well. So these are not good. Okay, when it comes into your water supply, it comes in contact with water supply, all right, you drink into it, it has been known, lead has been known to cause we call nervous system damage to the nervous system. Okay, so that's why the reason why we don't put lead, we do not use lead anymore in the making of water pipes. Last time, more than like 6 years ago, to make water pipes using lead, but now it with PVC, which is polyvinyl chloride. It's like some so it doesn't leach, because when you use some lead to make the pipe, the lead actually goes into the water. So so they found, the US has found that there's a lot high cases of mental retardation among children. Okay, it was the 1970s. So they started banning using lead in the making of these water pipes. Okay, now let's go to water pollution, the effect on what? Okay, on the human health. Okay, let's look at the different views. Number one is on the human health. Acidic gases and smoke cause respiratory disease. Okay, you learned this in Form 3 before. So when you breathe in all these gases like nitrogen, sulfur dioxide, and nitrous oxides and so on, you find number one, it's very, very pungent. It smells bad. And when it goes into your throat, you can feel the your sore throat. I mean, you have the sore throat, you feel that it's very uncomfortable, it's irritating. So when it goes inside it, okay, you have your breathing tube become inflamed. Inflamed means it really bengkak, right? It becomes infected, inflamed, 肿啦, we call it 发炎, infected. Then you become breathless because of the increase in the fluid inside your respiratory tube. So this passage becomes narrow, the lumen becomes narrow. Okay, problems like asthma, difficulty in, okay, bronchitis and so on. Okay, bronchitis, as these other respiratory diseases relate to we call it pollution, air pollution. Okay, irritates the eyes. Okay, eyes feel painful when you have all these gases. Skin diseases, conjunctivitis is the Asian layer outside your cornea. The first layer is called conjunctiva. So when it becomes infected, right, it becomes red. That's why you get a red eye. The 红眼, red eye is conjunctivitis. Okay, so you have to go and see the doctor. They put eye drop and so on. Now it also causes emphysema. Look at here, emphysema. Okay, this is maybe you may have forgotten. We have learned it in Form 3. So what happens is emphysema here. Let me show you a picture of emphysema. The normal lung with emphysema lungs. Okay, with emphysema. Learned earlier, the alveoli is this small little air sacs. Okay, which the size is very small, but because you have millions of it, it actually increases the total surface area. So each one is a complete circle, a complete, sort of like air bubble and air sac, we call it air sac, right? Which enables gaseous exchange, or we call it diffusion of gases. So it's outside there, you have a lot of blood vessels. So blood passes through, right? The ball passes through. This is not colored. This is the blue one. Blue one means what? Is the non we call it oxygenated blood. When it passes through here, then oxygen comes out. Alright, there's a revision a little bit. Oxygen comes out and it goes into your blood. It becomes red. So this one goes to your heart. Okay, so before it's blue, not really blue because just lack of oxygen. Goes in and then it comes to red. Okay, so this is how it works in your lung. So each of them should be a perfect shape of circle, right? The membrane intact. But when you have emphysema, you find that the surface area is very much less. Damaged alveoli, you can see that each one of these alveoli, you have less of this surface. It's bigger because circle have already more or less like already combined. Have less surface area. Actually, it's not complete. Okay, it's not complete. So when the surface is less, we call it the diffusion surface is less, the rate of diffusion will also drop. That means the oxygen delivery, oxygen going into your blood will be at a slower rate. Okay, this is the blood passing through here, and this is what should come up going out, right? Then you have less oxygen able to deliver because of less surface area. So this is like broken. Think of it is like the surfaces are not complete, it's broken. And you can see that the TSA is much lower. TSA stands for total surface area. Okay, so the diffusion rate of oxygen is much slower when you have emphysema, this phenomenon known as emphysema. Okay, if you calculate the surface area, this is much higher. They are all complete face. Here is broken down. So your surface. Okay, another picture you can see also clearly. Now here you can see the pattern here is like, each one will have a lot of these circles here, your alveoli, and then here you hardly see any partition. So you can see it's not very, very clear. This area is reduced. Okay, say reduce TS, and that affects your diffusion rate of oxygen and carbon dioxide. Okay, there's another picture here. This is emphysema, okay, which is not so many, this alveoli is not complete, it's broken down. And healthy one, now this is here. Now pneumonia, I just want to bring your attention. Pneumonia is not caused by pollution. Pneumonia is a disease of the lungs caused by bacteria. Okay, bacteria is a Bacillus thuringiensis. Pneumonia, it is caused by a infection. Okay, caused by infection. Bacteria or virus, I'm not too sure. I think bacteria, yes. So what happens is you have inflammation. Bacteria has found its way into the lungs, so it's actually breathing there, and as a reaction, your body produces a lot of phlegm. Okay, so this is not related to pollution. Just want to show you the difference here. This is not related to pollution, not because the air is dirty, but because it is because of microorganism. Okay, just for you to let you know. So this is emphysema. This is a healthy, just for you. Okay, let's come back to emphysema. You really got to see emphysema. Let's come back to the notes. All right. So causes emphysema. So the alveolar walls will collapse. all right, adjoin with each other. That means it reduces the total surface area. The symptoms: difficulty in breathing, you have lack of oxygen intake, not diffusion, and also coughing and feeling tired because of lack of oxygen. The first thing, because you have lack of oxygen, is because the first thing you feel is your tiredness, your energy level low. Okay, so feel sleepy and you don't have enough oxygen. Okay, next one. About next on human done. Now look at animals, the effect on animals and plants. Okay, animals and plant habitat. So here we don't talk about respiratory diseases. We talk about the acid rain, the effect to the soil, which increases the acidity. So it results in leaching of essential nutrients. So leaching means it runs away. When you have leaching, that means the soil, the nutrients that are in the soil, is sort of seeps into the water supply and is sort of washed away from the soil. It goes into the and the lakes. Okay, so that means the soil will be infertile, not fertile, because the nutrient has already gone. Okay, that's called leaching. Right? Usually flows into the rivers or the lakes, but it means no longer in the soil. Okay, next one. Acid rain that falls into the rivers and reduces the pH level of the water. Okay, as you know because the higher the acidic, the lower the pH level. Okay, so the acid, the water supply becomes acidic, so it's going to harm the fish and the other organisms. The air causes the soil to become acidic. Okay, and plants and the trees will die because they cannot tolerate such low acidity. High acidity but low pH. High acidity, low pH. Okay, destroys the leaves, impairs, damages. Slows down photosynthesis. Okay, and acid rain falling in the plants will change the color of the leaves. Sometimes how strong, depending how strong the acid change the colors of the leaves. So it may not be green anymore. It is leaves. So your rate of photosynthesis will be lower. Okay, next one. Next one, smoke. Yeah, when you have smoke, right, you have open burning some more, and the dust will cover and block the stomata. That's another effect of it. Block the stomata because you know the stomata is the place where oxygen and carbon dioxide comes in and out. So if you have the stomata blocked, that means your oxygen and carbon dioxide cannot go in and out. That means your plant cannot get these gases. It cannot carry out photosynthesis properly also. Okay, so it will prevent the absorption of sunlight because it covers the stoma, it covers the leaves, and leading to a reduction in the photosynthesis. So your plant will also produce less food. Okay, it grows less. And then when the toxic chemicals are in the air, it can also force the animals to migrate to another place. Okay, it affects the population and the distribution of these animals. And also, birds with long-term exposure to pollution have been found to have reduced egg production. That they will not be able to produce as many eggs. That means the rate of reproduction will drop. Okay, hatching, lung failure, all these are related to their lifestyle, their body system, all right. So it's not good for every animal and every plant. Okay, next for humans, the buildings. What is the effect on the buildings? All right, it corrodes because the acid corrodes metal structures. Also erodes the limestone because limestone also react with acid. When you throw a limestone into acid, it also dissolves. Okay, limestone is called calcium carbonate. So the acid rain will dissolve also metals, aluminium, copper, iron, steel, and also stonework. Okay, including your marble and so on. Okay, soot and dust also blacken the building. So these are the harmful effects to the building and infrastructure. Next, on the climate. When you have smoke, dust, and all this, they will combine with water vapor. They will form haze. So it blocks up the sunlight. Okay. It also increases there's a rise in the Earth's temperature. So when the greenhouse effect, you'll find the polar ice caps will melt. Okay. Water level will rise, and this one will continue to flood and so on. So it's actually one after another. It's all continuous. The effect is when A happens, it causes B. When B happens, it causes C. C happens, causes B. See, all of them are interrelated and interlinked. Okay, agriculture, it blocks the sunlight. When you have haze, it's not as shiny, it's not as warm, it's not as bright. You find it blocks the sunlight. So the soot and the soot is all the black things in the smoke. It blocks the stomata. It also blocks sunlight. It reduces agricultural productivity. That means the plant cannot produce as much fruits, as much, it cannot grow as big, it cannot grow as fast, it cannot produce as much food, and also the fruiting and flowering. So productivity is reduced. Okay, so how do we measure the quality of air? So you have this API lah, okay, air pollution index. Usually, how do you get this measurement? How do you get this API? Is measuring the amount of fine particles that are suspended in the air. So the higher the API reading, it means there are more suspended particles in the air. That means it's not good. Okay, a higher API reading means it's not good. A lower API reading will mean it's very good because there's very little things that are suspended in the air. So it's suspended because they're very light, so they don't really sink to the bottom. That's why you see haze. When you have this haze phenomenon, you find it's everything 蒙蒙的, blur, 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 isn't it? You find you can't even see, your visibility is very low. Maybe on a bright, clear day, you can see maybe 1 kilometer away. You can see all the way 1 kilometer. But when the visibility is very, we have haze, your visibility is further decreased. You find maybe you can only see a few hundred meters in front of you. After that, you can't see already. Okay, so fine particles are measured, those that are below 10 micron. Okay, 10 micron is very small. 1 micron is, if I'm mistaken, 1 micron is, this is called micron or micrometer. Okay, 1 micrometer is actually 1 over a million of a meter, or we call 1 over 1,000 of a millimeter. So like I mentioned, I just take out the ruler, all right, look at the smallest partition here. Look at the smallest partition here. You look at 1 mm, you divide that into 1,000. You divide that 1 small mm into 1,000. There is your 1 micrometer. Okay, and anything below 10 microns, 10 micrometer, is considered this suspended particles. It doesn't sink to the bottom. It's so light that it floats everywhere. Okay, so they are hazardous. They are also contains gases. So these are talking about particles. When you talk about this, these are talking about particles. Okay, so your air pollution index, how much is considered good? How much is not good? So when you have anything below than 100 is good. Okay, that means your air is considered okay lah, right? Very good lah, or very clean lah. That should be the normal day, the normal reading for every day. But when it goes up to 100 and above, 101, okay, that is considered unhealthy, slightly unhealthy if it's 100 below 200. Anything be above 200 is considered quite bad already. Okay, so you have cases more than 300 to 400. That's when you have to start wearing masks already. In fact, 200 and above, also you got to start think of wearing masks. Okay, so that will be the one we had a few years ago, right? Remember, we had this in Malaysia when you have forest fires burning everywhere. So you have this haze phenomenon. And at certain time, it was up to 100 plus and 200 and 300. So that's very bad, 300. Then you have to wear masks. And how to counter it? Normally, you try to stay indoors. Do not go out if you don't need to. And drink more water. Stay indoors and wear masks. This is all you can do. Okay? You can't really make the soot or all these particles go away. There's no way because it's too light. You can't trap it. Okay? It's too small. The only thing you can trap is your mask. A filter, because you must buy the mask which has able to filter out the microns, these small particles. Okay, next one. Let's look at thermal pollution. Thermal means heat. Okay, heat. So thermal pollution is the release of excessive heat into the environment. So usually the culprits are the ones in factories, in industrialization, when they have to produce certain products. They need to cool down the machines. So they use a lot of water, a lot of cool water. So when the water is, it cools down the machine. So the heat is transferred to the water. So now your water is hot. So they need to dispose it somewhere. So usually they will dump it into the river or dump it into the lake. Okay, and that's where the problem comes. Okay, so sources of pollution are this discharge of hot water. So where does hot water come from? From factories usually, and also nuclear reactors. Okay, luckily we don't have nuclear reactors in Malaysia, but we have countries which have nuclear reactors. They need the water to cool down that. We call it reactor because it produces a lot of heat when your uranium is bombarded with neutrons. So it splits, the atom split, and it's a chain reaction. So the heat builds up, it becomes hot. If you do not control it, like what happened in Chernobyl, okay, many years ago, 1986, and what happened in Fukushima, it blew up. There was an explosion because the nuclear reactor was too hot. They couldn't control it because in the case of Fukushima, because cooling station, all right, the facilities were damaged because of the heat and so on. So it couldn't cool down. It was out of control. So that's why there was a big explosion. And when that happens, radioactive particles or substances or the waste is actually spray out into the air. So everywhere in how many kilometers radius, the plants were all affected by these really radioactive substances. Okay, so that also happened and also electric power stations, you cool down the parts and the machinery, you need a lot of water. So after it absorbs the heat from the machine, it becomes hot. So what are you going to do? They pour it into the sea, or they pour it into the ocean, I mean the river or nearby water bodies. Okay, glass building is another thing. So contributes to the thermal pollution because glass actually reflects heat. So you have a city which all full of glass. Okay, glass looks nice, of course, very high class, right? Very nice. Inside could be cooling, right? Especially when you have tinted glass, but actually it's very bad for the air outside. Glass actually reflects heat, and light goes in, right? But the heat is reflected. So your temperature in the city is actually a lot warmer than it should be if you have a lot of glass buildings. Okay, so these are the two things that increases your pollution. Okay, so here look at number 3. So factories, okay, electric power stations, nuclear reactor, use water as a cooling agent because water has a high specific heat capacity. That what it means is it can absorb heat very well. Okay, it is a very good absorber of heat. So that's why they use water to cool down a lot of the machinery. Okay, so water has a high heat capacity. Yes, it can absorb a lot of heat. So it can absorb a lot of heat, it can cool down things. So it becomes hot. So what do they do with the hot water? They channel it into the rivers. So why don't you recycle the water to make it cooler? You can let it cool down, but that's going to take a long time. It's a long time if you want to release the air. So if you want to cool it down, you're going to use refrigeration. That's going to additional cost for the factory. If you want to cool down the water, you got to pass the water into a system where you actually you sort of like put it in refrigeration. You're going to end up using more energy. So they don't want to do that. The easy way out is use the river water, all right? Use it to cool down the machinery and dump the hot water back into the river. So that's what happens. So it is channeled into the river or the seas, causing the temperature to increase. So the water temperature of the river or the pond will increase. Now, what is wrong? Why is it bad for the animals? Why is it bad for the plants to have the temperature increase? Because when the temperature increases above the normal water temperature, so the normal water temperature that is best for them actually is around 20 something, 26 degrees Celsius, up to 30. 30 is considered a little bit warm. 26 is quite ideal. 26 to 28 degrees Celsius. Remember, this is the 27. This is the ideal temperature for photosynthesis. Okay, for animals, it's the ideal temperature of our body is 37. When you talk about plants, okay, the ideal temperature for plants to carry out photosynthesis, the optimal temperature is around 20 something. For water should be around that. Okay, at most up to 30. If anything higher than that, the aquatic organisms are going to suffer. What happens? The rise in water temperature will disrupt the biochemical processes of the body of the aquatic organisms. Okay, so they normally will not be able to survive if the temperature rises more than 30 and 30 something. Okay, 30 something is the internal temperature, but fish is cold-blooded. Okay, so cold-blooded, that means 37 will be a bit too warm for that actually. Okay, the temperature of the fish is not 37. It's for mammals we're talking about is 37. Okay, so example, the increase of water temperature can cause early hatchery of fish. That means the fish can hatch earlier. The eggs can hatch early, or they can also fail to hatch. That means it affects their life cycle. affects the life cycle. Okay, it affects their daily the metabolic processes and so on. So it will also increase the decomposition. Okay, so if you have a dead of these plants and animals inside, it will decompose faster. When it decomposes faster, higher microbial activity, higher activity of microorganisms. That means it increases the bio-oxygen chemical demand. The use of oxygen will be higher. That means the microorganisms are decomposing the whatever that's inside there, all the dead bodies of animals and so on. So it uses a lot of oxygen. So when it uses a lot of oxygen, that means the oxygen will drop. It becomes less and less oxygen inside the water. Okay, so it reduces the oxygen concentration in the water, and of course it suffers. Now the aquatic organism will suffer. The effect of hot water is actually the oxygen becomes less soluble. If your water is hotter, the temperature is warmer, the oxygen becomes less soluble. In other words, it means it contains less oxygen if the water is hot. So that's not good, isn't it? It cannot be good for the animals. It cannot be good for the plants. So it has to be lower temperature so it can contain more oxygen. Okay, so that's why hot water is no good for the water bodies, right? The body of water is going to affect the animals. Number one, it causes the oxygen to be less oxidation of these substances in the water. It increases the BOD, biochemical oxygen demand. Okay, and it also disrupt the biochemical processes of the animals in the water. Okay, so in order to reduce its absorption, so you see nowadays in our cities buildings, a lot of them use mirrors, okay, as walls. So it reduces the heat absorption. So the heat doesn't go in, but that's the least of the problem. Of course, inside is cooler, but what happens is it reflects the heat outside. So the outside environment becomes hotter when you have a lot of these glass buildings. So you see glass buildings reflect the heat sun ray, okay, into the next building, and you got a lot of it in the city, then you find the heat is trapped, also increases the greenhouse effect. I mean, it increases the global temperature. Okay, so you can see dissolved oxygen, look at the graph here, it will drop when the temperature rises. You see, it is what they call the inversely proportional. When the temperature increases, the dissolved oxygen will drop. So that means the warmer the water is, let's say 40 degrees, you find the oxygen content will be lower. When your water is cooler, the oxygen content is higher. Okay, next one, noise pollution. Okay, noise pollution, even though you find that it's more of the mental kind of thing. It affects us mentally when you have noise. It affects us mentally, emotionally when you have noise. Okay, let's look here. Excessive noise in the environment. So you're gonna talk things that makes a lot of noise. Okay, example, traffic. Okay, traffic means a lot of noise. And then of course music that you put that is too loud. Disco, all this is also noise. How do you measure sound? The loudness of sound is measured in a unit called decibel. Okay, D, small d, is not a linear scale. It is actually exponential scale. Okay, so it's not linear. It's not like it's like a straight line that you can see the graph. It is actually exponential. The next number, the next figure is more than double that one. So the higher the decibel is, the louder the noise. Okay, so now WHO has said that if your noise level reaches 80 decibel and above, 80 decibel and above, it causes discomfort and your quality of life will be affected. Okay, so usually not more than 55. 55 is the general threshold that we find is comfortable for us to have a a conversation with people, and it's not too loud, right? And we are not affected mentally. So what are the effects of noise pollution? Including number one, it damages your eardrum. Okay, loud noise has an effect. It can even puncture your eardrum if it's loud enough. Some people sometimes hearing effect because they've been exposed to loud noise for a long period of time. So hearing problems will be not good because you can't hear something. Sometimes you have warning signs. Sometimes your warning sounds. When people honk at you, that means it's a warning, and it becomes a problem if you cannot hear the honk. Okay, Headaches, yeah, it causes headaches when you have noise pollution. Okay? Emotional and mental disturbances. Emotional, you don't feel nice, right? Because it's too noisy. You cannot feel at rest. You feel like you are so disturbed. Cannot concentrate, cannot think properly. Increased heart is also psychosomatic. From your mind, it also affects your body. Okay, so your heartbeat will increase. Okay, you feel restless, respiration rate high, then you get depression and so on because of the environment that you're in. It is not comfortable for you. Okay, and of course, hearing deafness, it causes deafness. Extreme loud noise can actually puncture your eardrums. Okay, so sources of noise pollution are aircraft and jet planes. So people who work the runways, people directing traffic in the runways, they always wear a muffler to protect ears from the loud noise of the engine. For the airway or the airport, the jet that is taking off, the kind of sound can go up to 120 decibel. Okay, that is quite actually can puncture your eardrums, So if you do not wear that, long exposure over a long certain times, you find that your hearing becomes less sensitive. Then you find that you have hearing loss. Okay, trains, right? Construction site people, repairing the road when they have to dig up the road and so on, the concrete, the tar roads, you find something to break, the sound is very disturbing. Machines, sounds of machines, traffic, all this is very disturbing. So let's look at the range here. Around 50 to 60, this is your talking range, normal voice. You're not shouting, you're just talking at a normal range. Okay, very noisy above that, not so good. Cycle, okay, no way. Then you have uncomfortable, you have jet planes flying around or over your house. Rock band, okay, now this one is very, very loud. It damages your eardrum. Okay, low is also good, right? But it's not loud. Too high is not bad. It's very bad. Okay, now lastly, let's finish with the human population growth. Okay, so now you notice that when you talk about we plot the growth of human population over centuries now, you notice that it is not a straight line. It is called exponential. That means it suddenly will shoot up. I'm sure you learned this in maths, right? You have exponential graph. Exponential graph is always a curve. It is a straight line. So it's like exponential. How do you get exponential? It is the power. Like for example, 2 power 1, 2 to the power 1. Then the next number 2 to the power 2, 2 to the power 3, 2 to the power 4. If you find exponential, if you plot the graph, it doesn't go in a straight line. It curves up like this. So this is exponential graph. Suddenly, within a short time, you notice that it shoots up. Okay, so this is the shape of the graph of the human population of the earth nowadays. The population is really growing too fast. There are reasons for it. Why are we producing so? Of course, not every country is the same. Okay, there are certain countries like in Japan and Singapore, you find that the population growth is so slow. People do not want to have children. Okay, so this is their mentality of certain people. They do not, maybe the young people, they're too busy working. They do not find the time to have family and all that. They do not want to children to tie them down. So it's their commitment to their work and so on. Of course, there are different reasons. And also on the other extreme end, you have in Africa, when the population rate is exploding, because number one, they don't have, women, they have this mentality that they're supposed to, they have to get married at a young age, and they have a lot of children. They do not know about contraceptives. So after giving birth, they give birth again and again and again. In their whole lifetime, they can give maybe 12 children, 1 dozen or even more. So the population of certain countries, the growth rate is so different. Okay, so in Korea, Japan, and in certain countries like even in Sweden and all that, they're very, very married children. So you can find, generally speaking, there is an increase in the total over the many, many years, hundreds of years. Okay, so what are the things that contribute? How many years, hundreds of years ago, suddenly it shoot up around in the 18th century or 19th century here, suddenly, because of industrialization. Okay, and because of the discovery in medicine. Okay, so people generally now live longer. You have longer lifespan because last time sanitation was very bad. Okay, they didn't know why people die. People start dying like fleas. People dropping dead. Because let's say there's an epidemic, there is a spread of disease, and they do not know that they spread by touching. So they do not know how to take precaution. So people start dying because they spread all over, and also didn't know that rats brought illnesses. They are the vectors which carry pathogen. So their surroundings are very dirty. They didn't know how to kill rats. They didn't know what to do with it. So they start to spread the disease very, very wide lah. Okay, that's why people die. But we know sanitation. We know about hygiene. So we know how to look after ourselves. So we have longer lifespan. Okay, number 2, better medical facilities. We have invented antibiotics. We also know about vaccines. So we know how to look after ourselves. We want to prevent getting diseases. Increase birth rates. Okay, certain countries in Africa, okay, where you have children, women, they get married early because probably they don't study, they don't have a job, they don't have high education. Okay, their living conditions are so poor. Sometimes parents, they sell their children off just to get money. Okay, because they have so many children, they sell off the rich family and they get money. That's it. Okay, and then the young girl who serves in the country, in a new family, probably they sell it as a bride, or they buy it as a bride for their boy. So they get married very early. Maybe at the age of 15, they already start having children. So increase birth rates. If you start having children at 15, imagine the age of 16 years old, you can have how many children? You can have more than us. We normally, okay, in our educated society, we just have about 2 or 3, even 4 the most. But in countries which are so poor, they will have very high rates of they have very high birth rates. Okay, low death rates because people generally have better health lah. Okay, so here populations now. Why is population increase? Because when population increase the feed, okay, it will affect the way you look at growing food. You got to grow them faster. You got to produce more food for people, to the human, more human. So as the population rises, there's a need for better facilities, homes and hospitals. You also need how to grow, okay, better quality and faster. Another thing is deforestation is one of the effects. When you have population rising, you need to build houses for them. So you got to cut down trees. You got to cut down, clear the forest. You have to find farming land. Okay, you got to make houses, make farmlands. All right, you got to got to build new farms. You also have to make roads. So that's why you got to cut down trees. You got to clear up forests and result in extinction of animals, global warming, and so on. So that's why humans are environment. The more humans there are, the less of nature there will be. Okay, so the impact. Okay, let's look at the impacts. So question normally asks you about this thing. Impacts. What causes cause and effect? Impact means the effect lah. It's the same thing. Okay, for how to answer questions, what were they asking for? What is the effect? Effect. How does it affect? Okay, of let A. A happens, so what's going to happen? B is going to happen. That's your effect. One, you're going to increase the global warming. You're going to make these things happen. Climate change, because more forests will be cleared for what? For making houses, for new factories, for planting, and so on. So when more forests are cleared, you have more carbon dioxide. That will lead to more increase the global warming issue, and of course, serious climate change. Okay, number 2, land and soil degradation means land and soil quality becomes worse. Because when you want to grow more food, you want to make sure they grow faster, you got to use more fertilizers. Okay, more fertilizers, and that will also for the case of eutrophication. You put too much fertilizer, it goes into the water and you will get algal bloom. Okay, so excessive fertilizers does not maintain good soil structure. Okay, and frequent plowing of crop, you have to plow. Plow means you got to dig up the soil to make it aerated, to make air go inside. So you got to membajak. Also destroys the soil. Then you have soil erosion. Okay, because you cut down the trees, you find that it's no good to hold on to the soil. Depletion of natural resources. When you got a lot of human, you gotta make sure you need to use a lot of resources, using more minerals, right? More petroleum and so on. And these are up, and because they are non-renewable, that's even worse. Okay, they are non-resources. Pollution, definitely. More humans means more rubbish. Correct or not? Okay. Everybody imagine everything has to be wrapped nowadays. So plastic will increase because more people buy the thing, you got more rubbish. Okay. Pollution, excessive use of fertilizers, pesticide, because you need to increase the crop, you want to make them grow faster, you're going to put a lot of fertilizers. You will cause air and water pollution. Industrialization, okay, factories, okay, will increase more waste. Okay, more waste because you have given more waste, okay, more rubbish. Degradation of ecosystem, the ecosystem will be affected. Okay, you will have many land aquatic systems will be degraded or destroyed. Got that cleared forest gonna kill a lot of animals, okay, and so that ultimately you have loss of diversity is always the end, loss of diversity, and of course extinction of species. Okay, so these are the things that why our human, all right, explosion, pollution, these are the things that actually affect the environment. So all these are different aspects you can talk about. So it's all very general, but it's all in your head. I'm very sure all of knowledge on this. You just need to know how to write it. Okay, so now I say it's going to be a short one, but I mentioned about it's almost an hour already, yeah, because I have a lot of explanation. Okay, so I hope that helps you to write a good essay. You want to write part here. So you cannot remember all the other facts. I do encourage you to try all these questions because the facts are all there. You just need to know how to put it in. So we will meet again in Google Meet afterwards, discuss some questions with you. So for the time being, okay, I will say goodbye now. And the next lesson will be on 10.2, okay, this Saturday. Okay, so I will see you and all those who are out there, support my channel, and I'll see you in my next lesson. Okay, bye.